Hello, everybody. We are back with another visual pattern challenge. So here's your visual pattern today, and here's step one, step two, step three. And the challenge is to look at this pattern and see if you can figure out how many boxes are going to be in step number 4. And if you can, how many in step number 43. And in doing that, you probably will want to come up with an equation that you could use to predict the number of boxes in any step at all. So that's the challenge. If you choose to accept the challenge, go ahead and pause the video and give it a shot. All right, so I think this particular challenge is really, really difficult. And we might be able to get step 4, but coming up with an equation, I think is going to be just a bear. So if you weren't able to get all the way through this one, don't sweat it too much. Unless you've seen a pattern like this before, this is a really hard one to have intuition into. But let me see if I can do some work on explaining what's going on here. First of all, if we look at the pattern, I'm seeing this kind of L shape here, and then here's that L shape again, and it looks like we've added a diagonal. And then let's see, I'm going to just color in the pattern for step 2, and then yeah, it looks like we've added a diagonal on it again. And so if we're going to get step 4, I think what we do is just add the next diagonal, like so. So that'd be adding 1, 2, 3, 4, 5 more boxes. So we had, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 plus 5. So it looks like 15 in step number 4. So that's my prediction for step number 4. Does that look right to you? Is that what you got? I think that's correct. Now, for the pattern as a whole, to try to work on an equation, I think this one is pretty baffling. It sort of looks like a square that's had a big chunk bitten out, right? So here's a 2 by 2 square with a 1 box bitten out. Here's a 3 by 3 square with 3 boxes bitten out. Here's a 4 by 4 square with more boxes bitten out. So what the equation is going to be for that is not really clear to me yet. I think we should just be methodical and systematic and look at our numbers. And then we can verify, is this really a quadratic or not? So I'm going to put the step number and the number of boxes, and we'll take a look at that. So step number 1 has 3 boxes. Step number 2 has 6. Step number 3 has 4 more than that, so that's 10. And step number 4 we're predicting has 15. When we analyze numbers in a pattern like this, we look at the differences from step to step. So 6 minus 3 is 3. 10 minus 6 is 4. 15 minus 10 is 5. We do not have a constant number in the differences. So that means it's not a linear pattern. We can't use that equation for a line to model this. And in that case, we usually take the difference of the differences. So 4 minus 3 is 1. 5 minus 4 is 1. When that is a constant, and it is, it's 1, that means it is a quadratic pattern, and x squared is going to be part of this somehow. But how exactly? I mean, you could bang your head against this one, trying out various combinations of equations with x squared in them. There's 3 here, so is this x squared plus 2? Well, that would fit for step number 1. Would it fit for step number 2? Yeah, 2 squared plus these 2. Oh, hey, this is looking promising. Let's try step number 3. If it was x squared plus 2, it'd be 3 squared plus 2. So 9 plus 2 equals 11, but we have 10. Oh, and for step 4, that'd be 16 plus 2. So that's more than 15. Huh. So that looked really promising on the first couple steps, but then it stopped working. So what is going on here? Well, we did one pattern back a few episodes where we had something like this. These are actually a special set of numbers called triangular numbers. And you might see that in the pattern here. They're kind of arranged in the shape of a triangle. The equation for the regular set of triangular numbers is x squared plus, whoops, no plus there, plus x divided by 2. So maybe this is our starting point. I don't think this is actually going to work for the whole thing, but maybe that's our starting point. So let's fool around with that one. And I only got here because I saw that pattern of triangular numbers before, and so I happen to know this. So if you didn't get to this point, don't feel too bad. So if I put in 1 here, that'd be 1 squared plus 1 divided by 2. That would equal 1. And then we've got a couple more. I'm gonna wait before I decide this is plus 2. Let's look at the second one. So 2 squared plus 2 divided by 2. So that'd be 4 plus, that would equal 3. Oh, that's interesting. It gives us this portion, so it gives us the previous pattern. Let's see if that holds for the next one. In step 3, it'd be 3 squared plus 3 divided by 2. So it's 9 plus 3 is 12 divided by 2 is 6. Aha! So that gives us the amount in the previous step as well. Isn't that interesting? So this is definitely intriguing. We just have to add something else every time because these numbers are coming out smaller. And we can't just add 2, right? Because this, in the first one, we're 2 away, but in the second one, we're 3 away, and in the third one, we're 4 away. So it might be x squared plus x over 2 plus what? Well, it changes by 1. So it's going to be the step number. So that'd be x. That's going to go up 1 every time. So that's great that it's changing by 1. But then that still doesn't work out for step number 1, right? This chunk equaled 2 plus the step number 2 plus 1. Sorry, this equaled 1 plus 1 is 2. So we'd need 1 more. So that's my guess. Let's see if that works for step number 2. So 2 squared, well, we know that part. We did it already. 2 squared plus 2 divided by 2 equals 3. And then plus the step number, that'd be 3 plus 2 plus 1. Well, that is 6. Okay, let's do the next one because we have to verify it works for all these steps because remember, one of our guesses worked for steps 1 and 2, but not for 3. So let's go up to step 3. So step 3, this first chunk equals 6 plus the step number would be 3. 6 plus 3 would be 9 plus 1 more would be 10. Ooh, so that worked for step 3. Let's just try step 4 really quickly. I'm going to do it up here where I have more room. So the whole equation is going to be step 4 squared plus step 4 divided by 2 plus step 4 plus 1 more. What does that equal? 16 plus 4 is 20 divided by 2 is 10 plus 4 plus 1, that is 15. And that's exactly what we predicted for that step. So I think this is our equation, y equals x squared plus x divided by 2 plus x again, and then plus 1 more. That is kind of crazy. Now, figuring out step 43 is a fair amount of work. We have to do 43 squared plus 43 and then divide that by 2 and then add 43 and add 1 more. So let me punch this into my calculator. 43 times 43, that's 1849 plus 43 is 1892. We're going to divide that by 2 and that's 946. So let me jot that down. 946 plus 43 plus 1, that should equal 990 in step 43. Well, did you get that one? If you got step 4, good for you for seeing that pattern and sussing all that out. If you got step 43, I am impressed and I want to hear about it. All right, well, thank you, everybody. See you next time.